Interstellar structures and phenomena continue to puzzle scientists to this day. According to the latest findings, previously unexplored forces and objects are hidden in the seemingly empty darkness between the stars. Some researchers suspect that millions, perhaps even billions, of interstellar objects are passing through our solar system unnoticed. These alien visitors come from foreign star systems and could provide important clues about new forms of matter or unknown physical processes. What do a mysterious comet, thousands of rock fragments in the vicinity of Earth, and the findings of the legendary Voyager probe have in common? Quite simply, they reveal little-known or completely new details about a barely explored area of the universe. Interstellar space is an apparent void whose distances and dimensions are so vast that they are beyond our imagination. Although space may seem empty and meaningless, the interstellar medium, or ISM for short, contains many of the most important structures in the universe. The latest research even shows that extraterrestrials could be leaving interesting traces in the ISM. Oumuamua and the Amber Comet, the first official visitors from interstellar space, were milestones in astronomy and quite a surprise. In 2017, astronomers in Hawaii reported an astonishing sighting. The mysterious object Oumuamua had just passed Earth at a speed of about 315,000 kilometers per hour. Its sudden appearance, elongated shape, strange movement pattern, and lack of typical comet characteristics led scientists to seriously question the true origin and nature of the object. Some researchers suspect that it's a natural interstellar asteroid, while others have even suggested that it could be an artificial structure. The most daring idea saw Oumuamua as a spaceship or well-camouflaged probe from an extraterrestrial civilization. What is certain is that the thin object, about 1 kilometer long, came from outside the solar system, and this was initially considered a completely new phenomenon. Things got really strange when, shortly afterwards, another fascinating object appeared from the depths of interstellar space. Comet CL 2014 UN 271, known as the Bernardinella-Bernstein Comet, was only classified years after its discovery as the largest comet ever observed, with an estimated diameter of almost 120 kilometers. This object was truly gigantic, and, of course, not entirely harmless. Fortunately, the interstellar giant's path never came close to Earth's orbit. The Bernstein Comet was particularly interesting because it, too, clearly came from outside the solar system. Could it be a coincidence that two interstellar visitors appeared in quick succession? No, say the researchers. There will be even more interstellar visitors in the future. It's also very likely that they are not really new. We are only seeing them now because our technologies are improving. Now, an interesting theory has emerged that there may be a large number of interstellar rock fragments in our solar system that have not yet been detected. First, researchers examined thousands of smaller rock fragments that occur naturally in Earth's cosmic environment. We're now able to study these objects well with our telescopes, and lo and behold, there were some surprises. The majority of the rock fragments examined could even be of interstellar origin. There are several million to billions of these smaller fragments throughout the solar system. This could mean that massive amounts of matter from other solar systems, and possibly also debris from distant planets and other objects, are present in our solar system. The sheer number suggests that the fragments were also absorbed by our solar system during its journey through the interstellar medium and bound by the gravity of planets and the Sun. Our solar system is essentially sucking up space debris. Each of these chunks would be of great interest to science because all objects that provide clues about material and structures originating from outside our solar system are extremely valuable for research. They could provide information about how other star systems develop and what types of objects exist in interstellar space. Scientists now want to study some of these objects in detail using special telescopes, or even send probes into Earth's environment to collect some of these potentially extraterrestrial visitors and bring them back to Earth. The cosmic matter between the stars, the interstellar medium, was long considered a rather boring, vast, widely scattered collection of gas, dust, and high-energy particles. The enormous void that fills the space between star systems was long regarded as a big nothing. This view is now changing. The ISM only appears empty at first glance. In reality, it is one of the main stages for cosmic evolution. It is the structures and processes in its apparent emptiness that significantly influence the formation of stars and planets. The gas in the ISM consists mainly of hydrogen, the most common element in the universe. In certain regions, this gas condenses and can lead to the birth of new stars. When a supernova explodes, it ejects high-energy particles into the ISM, causing chemical elements to spread throughout the universe and then accumulate in certain places in the form of molecular clouds. These molecular clouds are the breeding grounds for new star systems and planets, and they can contain complex organic molecules that are a key component in the emergence of life. In addition to gas, the ISM consists mainly of cosmic dust, more precisely, tiny silicate or carbon particles. These dust grains absorb and scatter starlight, causing optical distortions that researchers refer to as interstellar extinction. These particles are also crucial for many chemical reactions that serve as catalysts for molecule formation. So, there's a lot going on in the ISM. If we look at the role of the ISM in the formation of planetary systems, the full beauty of this interplay becomes apparent. As a star develops from a gas cloud, dust grains remain behind, gradually condensing into asteroids, moons, and planets. This is how our solar system may once have formed from an interstellar molecular cloud. Deep behind the visible object of the universe lie gigantic thread-like structures made of dark and finely visible matter. These filaments connect large visible accumulations of matter, such as galaxies and galaxy clusters, and probably also contribute to their formation. The cosmic web acts like a fungal mycelium and very likely pushes matter from the depths of the cosmic matrix into the visible realm in ways that are as yet unknown. Galaxies and entire galaxy clusters move along the filaments, which are among the largest known structures in the cosmos. Some of the longest structures known and studied to date extend hundreds of millions of light years through the interstellar and intergalactic medium. A particularly impressive example of such a filament is a connection between the Milky Way and the Virgo supercluster. This structure extends over millions of light years and shows how infinitely many galaxies are connected to each other through the cosmic web. Filaments are most likely formed by gravity and interactions between dark, invisible matter and baryonic, visible matter. Dark matter plays a crucial role in this process, as it serves as an invisible framework and probably also as a kind of dynamic force that attracts and shapes visible matter. Large, almost empty areas can form between the filaments, known as voids, which contain only a few galaxies. Voids arise simply because there are no filaments, only very few. Why this is so is one of the greatest mysteries of science at present. Strictly speaking, the filament structure does not follow the rules of the Big Bang and the homogeneity of the universe. Recent research shows that this gigantic cosmic network is not static. Filaments rotate, and this rotational movement is probably even an accelerator of matter formation. This could even mean that our universe is formed from these voids or even deeper structures and did not have a single origin in time or space. With the help of modern telescopes such as a very large telescope, researchers are still taking higher resolution images of these structures to uncover the secret of the universe's blueprint. Are there warp bubbles and wormhole gates in the interstellar medium? This question fascinates scientists and science fiction fans alike, and researchers may have now found the first evidence of a real shortcut through space-time. Warp drive is based on the concept that space-time is compressed in front of a spaceship and expands behind it. This would allow the ship to move in a bubble and slip through space-time folds without exceeding the speed of light. For a long time, it was doubted that this could be possible in real life, until Mexican mathematician Miguel Alcubierre proved that it is theoretically possible, even without breaking Einstein's laws of relativity. The catch was the extreme amount of energy required, which Alcubierre solved in his calculations by using exotic matter. And that has another catch. We know very little about this type of matter and cannot yet use it effectively. But what if warp bubbles exist naturally in the universe or space-time folds that we can use without expending a lot of energy? Wormholes are tunnels through space-time that were first described in theory in the 1930s by researchers Albert Einstein and Nathan Rosen. Einstein-Rosen bridges are even logical conclusions based on the calculations of the general theory of relativity. They connect two distant points in the universe. The entrances to such tunnels could be located in the ISM and even on our doorstep. Black holes have also been discussed. Some scientists speculate that certain cosmic phenomena in interstellar space could be evidence of natural or artificial wormholes, or even manipulations of space-time created by extraterrestrial intelligences to travel safely through space and time. The Voyager 1 and Voyager 2 space probes are the first man-made objects to reach interstellar space. Voyager 1 crossed the magical threshold on August 25, 2012, followed by Voyager 2 on November 5, 2018. As the probes left the heliosphere, they discovered that the density of interstellar plasma waves is higher than expected. Since then, we have learned that the interstellar medium is much more compressed than previously thought. One of the most fascinating discoveries was the so-called hydrogen wall at the edge of the solar system. There, at the boundary between the solar wind and interstellar space, researchers discovered a collection of hydrogen atoms created by the interaction of these two environments, a kind of glowing curtain at the edge of our solar bubble. Later measurements provided another surprise. In 2020, Voyager 1 detected an unknown but persistent and strikingly low-frequency plasma signal. Unlike the short-lived plasma shocks caused by solar flares, this signal was steady and constant, and it appeared to come directly from the interstellar medium. This cosmically quiet hum could be an electric current in interstellar space, probably caused by dense and magnetically charged structures moving far outside the heliosphere. However, there is also a far more fantastical explanation, which suggests that the hum could be coming from a technical device created by an extraterrestrial intelligence, such as an artificial space-time tunnel. Interstellar space stations, or spaceships, take the idea of the ISM as a playground for extraterrestrial activity one step further. The large empty spaces could serve as mobile habitats for advanced civilizations that don't want to be confined to a single planet. If such structures really exist, there would be enormous constructions that could easily exist between star systems. If a civilization has mastered interstellar travel, it could maintain autonomous cities with their own ecosystems, energy sources, and advanced technologies for self-sufficiency in space. An exciting theoretical example is a generation ship, a spaceship so large that entire generations of humans could live and work in it as it slowly moves from one star system to another. Such ships would have to be extremely durable and, of course, have far more advanced propulsion systems than we can imagine today. However, we can assume that civilizations living interstellar would have mastered this problem as well. Click the subscribe button now and enjoy new videos on a regular basis.